So these problems are doing what I did up in the first problem on the first video, where you can synthetically divide or you can evaluate the function at that value. So if we evaluate f of at -3, that means we're going to put -3 in for n everywhere we see it. Okay, and this again is just to show you that synthetic and evaluating the function like this will both tell you if a number or value is a factor or not. So, so then we're just going to evaluate. So we're going to say -3 to the 4th power is 81. I'm just checking myself because it's been a long day. Yep, 81. And then we've got -3 to the 3rd is -27 times -2 is a +54. We have -14 times -3 is +42. 9 times -3 is -27 plus 15. So we're just going to enter these into our calculator. 81 plus 54 plus 42 minus 27 plus 15. And we get a value of 165. So therefore, n plus 3, okay, because n equals -3 is the value, the factor is n plus 3 is not a factor of that polynomial. Okay, so then if we look at continuing down onto the next page of this, just actually dividing those. So we've looked at some already that are just basic binomials, okay? But I want to look at a couple that are a little different. So if we look at maybe 13, or any of these, 12, 13, or 14. So if we look at 13 first, we notice that first of all, it's not an n plus a number. It's not a coefficient of 1 in front of the variable. So when we have to really think about what we're going to divide. So we have to set that divisor equal to 0 and solve. So 7n equals -7. So n equals -1. So really, we're doing synthetic division with -1. Okay, so then we have 7, 56, 42, and -9. So now we're not really trying to see if it's a factor or not. We're just simply dividing that. So we're going to get our answer. So we're going to bring down our first term. 7 times -1 is -7. 56 plus -7 is 49. 49 times -1 is -49. 42 plus -49 is -7. -7 times -1 is +7. -9 plus 7 is -2. So now we're going to say, well, obviously, if we looked at this and we were just curious if it was a factor, we would go, nope, it's not a factor. So we know there's going to be a remainder. So now we're just going to write our answer, our quotient of this value. So since it's 7n to the 3rd, this is going to step down 1 exponent. So it's going to be 7n to the 2nd plus 49n minus 7 minus 2 over our divisor of 7n plus 7. Okay, so that's what it means when it just says to divide, is to actually divide out with synthetic and put what you had. So if you were to have done that with long division, you would have gotten the same answer. To me, synthetic is much quicker and a lot easier to think about. So that's why we often use synthetic over long division. Now, if we look at number 14, okay, 3x minus 2, we're going to have to solve that one for equal to 0 and solve for x. So 3x equals 2, so x equals 2/3. So we can do fractional numbers in synthetic, okay? And I thought I had an example on here, but just make sure in your dividend that if there's any exponent, like if this skipped the squared term, you would have to put a 0 in as a placeholder, just like you did in long division. So I'm going to put my coefficients, 3, 22, -4, -9. I'm going to bring my first term down. So 3 times 2/3 is 2. Okay, add 22 plus 22 plus 2 is 24. Okay, 24 times 2/3. Okay, so that's 16. Negative 4 plus 16 is 12. 12 times 2/3 is 8. Negative 9 plus 8 is negative 1. So our answer is, since it's cubed, our answer starts with squared, 3x squared plus 24x plus 12 minus 1 over our divisor, which was 3x minus 2. Okay, so next week we'll continue to work with synthetic and actually continuing to work with polynomials. So this is just one aspect. We'll use this to actually determine all the roots of problems and of polynomials and such as that. So go ahead and finish this, and then make sure you take your quiz in Edge and complete the weekly exit ticket.